Okay, we're going to discuss graphing exponential decay functions. Decay functions, examples of a decay function would be like when you take antibiotics, the bacteria, um, they go away basically because the antibiotics are fighting the bacteria. So that's an example of a decay function. Also, if you've ever tried to buy a used car or sell a used car, you're going basically off the Kelley Blue Book, which goes off what year your car is and how good of a shape it is. That makes sense. So anything like that is a decay function. A TV that's not flat screen, they are not worth very much. So that's an example of a decay function. You could buy a new television for about 400 bucks and then in a few years it's only worth 100 bucks because of technology. So those are all examples of decay functions. Our basic function is going to be y equals a times b to the x. And if you look at that, you probably might say, hey, that's the same thing as the exponential growth function. And you would be right. Except b now, instead of b being greater than 1, b is between 0 and 1. So we have 0 right here. B is between 0 and 1. So for example, b could be 3/4. It could be 0.5. It could be 5/9. It could be 0.2. So anything between 0 and 1 is going to be a decay function. So our basic graph, again, is b is between 0 and 1, and this is the parent function. So we have f of x equal b to the x. So when I graph that, again, you kind of know the shape right away. So if we graph 0, if y equals b to the x, if x is equal to 0, then we have b to the 0. Anything to the 0 power is 1. So that's why we have that point on there. And then for x equals 1, that would be b to the first. And then that's going to be lower than 1, so somewhere right here. So it's going to start really, really high and then get super close to the x-axis. So the x-axis is the asymptote. Okay. All right. It's a decay function, so there's no way we can have negative. Like your TV will not be worth negative amount of dollars, unless I guess you have it, take it to the dump, but that's a different story. So it goes really, really close to the x-axis, which is again y equals 0, but it never actually reaches 0 or goes below that. All right, and your domain again is all real numbers. That's kind of nice. And then the range is going to be y is greater than 0. And eventually that will be k again when our friends come back. All right, so for our first example, we have y equals, I don't know why that's there. We have y equals 1/2 to the x. So we know it's a decay function because 1/2 is less than 1. So we're going to graph a bunch of numbers here. So make sure you have all the numbers. So we have x, we have y equals 1/2 to the x power. Again, if we don't know what that looks like, we're going to start off with a bunch of numbers. So for -3, we're going to do 1/2 to the -3 power. That's the same thing as 1 to the -3 over 2 to the -3. So those are both unhappy upstairs and downstairs. So we're going to flip-flop in and we're going to get 2 cubed upstairs and 1 cubed downstairs. When we simplify that, that's 8 over 1 or just 8. So pause the video and go through these. Find -2, find -1, find 0, find 1, find 2, and 3, please. So pause the video right now and find -2, -1, 0, 1, 2, and 3. Pause it right now. Find them. Don't watch me. Try it yourself. All right, and then hopefully you've already fast forwarded this part and you're just checking your answers. This is 1 to the -2, 2 to the -2, you flip-flop it, you get 2 squared over 1 squared, which is 4. Okay. For -1, 1/2 to the -1 power. We distribute that negative. We get 1 to the -1 over 2 to the -1. We flip-flop it, and we get 2 over 1, which is just 2. 1/2 to the 0 power. That one's nice. It's just equal to 1. 1/2 to the first power is 1 to the first over 2 to the first, which is just 1/2. And 1/2 squared is equal to 1 squared over 2 squared, which is 1 squared is 1, 2 squared is 4, so that's a fourth. And then we have 1/2 cubed, which is 1 cubed over 2 cubed. So 1 cubed is 1 and 2 cubed is 8, so we get 1 over 8. All right, so if you don't know how I got these numbers, please rewind and check my work. Please listen to the video because I talk through it as well. It helps to hear it as well as see it. So, and then when you have all these, we are going to graph them now. So we start with -3. Here's x and y are right here. So we have -3 and a +8. So right there, -2, we're going to graph to 4. Hold on, that would be 6. Let me move that one up. There we go, at 8. And then -1 is a +2. 0 is 1. 1, we get 1/2. So they're going to be really hard to draw. 2 is about 1/4. 3 is 1/8. So it gets really, really close to the x-axis, but never actually touches it or crosses it. Okay, so that is our graph. So it starts super high and then ends low. Okay, all right, just like a new car. New car has a very high value, and then when it's 20 years old, it's got a very low value, if any value. So that's how you remember decay functions. And then our domain is all real numbers. Our range is y is greater than to 0, and eventually that will be k. Right. So these two, if you can try them on your own, great. If you need to watch me, that's fine too. But when you feel comfortable, pause the video and see if you can finish the problem. Fast forward to the answer. If you get exactly what I did, great. If not, please rewind, and I talk through everything. So, but please, as soon as you're comfortable, try this on your own. The more you can do on your own, the better you will understand it. But for this one, so if you can take it from here, great. If not, if you need to know how to get started first, we are going to, again, order of operations, we are going to do this part first and then multiply by 2. Right? And so numbers to use are going to be -2, -1, 0, 1, and 2. And just like yesterday's notes, when we get comfortable enough, 0 and 1 are going to be our main x values. Right? So for -2, we have, this is going to be 2 times 1/4 to the -2 power. Order of operations, we're going to do the exponent first and then multiply by 2. So we have 2 times 1 to the -2, distribute that exponent, 4 to the -2. They're both unhappy, upstairs and downstairs, so we're going to switch them. And so we have 2 times 4 squared over 1 squared. So 2 times 4 squared is 16. So we get 2 times 16, which is 32. Okay. So if you can do the rest of them all by your lonesome, please pause the video and try them. I talk through everything, but if you can do the rest by yourself, then you are good to go for this part of the lesson. All right, so pause it if you can do this by yourself. If not, I will talk through it. All right, so we have 2 times 1/4 to the -1. That's the same thing as 2 times 1 to the -1 over 4 to the -1. So I flip-flop it. I have 2 times 4 to the first over 1 to the first. So that is 4 over 1. So we multiply straight across and we get 8. 8 over 1 is the same thing as 8. So see if I can move these. All right. So then when we plug in 0, 0 is kind of nice. We have 2 times 1/4 to the 0 power. We do this part first. So we have, this is equal to 2 times 1. Anything the 0 power is 1, and 2 times 1 is 2. Our next one, we plug that in. We're going to get 2 times 1/4 to the first power, which is the same thing as 2 times 1/4. Remember, we multiply straight across when we multiply fractions. This is going to be 2 over 4. When we reduce it, it's 1/2. Okay. And then for 2, we plug in 2 times 1/4 squared. Okay, that's the same thing as 2 times 1 squared over 4 squared, which is the same thing as 2 times 1 over 16. So when I multiply straight across, I get 2 over 16, and to reduce that, it's going to be 1/8. Okay. All right, so if you got those and you paused it, awesome job, right? If you didn't get 1/8 or 1/2, please rewind. I talk through it, so please figure out why and what. If you still have a question, pause the video, write it down, and ask me in class tomorrow. But you guys can totally do this. So, all right, so our asymptote is still on the x-axis. We have -2 and 32. So that's a bit higher than my graph, so I'm just going to label it right here. You can do the same. For -1, that is 8. So right about there. 0 is 2. +1, I get 1/2. So, and then 2 is 1/8, so a little bit closer. All right, so my decay function starts high and ends low. Doesn't cross the x-axis, doesn't touch it, but gets super close to it. So the domain is what? What would the domain be? Write it down. All right, if you did all real numbers, you are awesome. Write down the range, please, before I do. Write it down. Okay, y is greater than 0. Good job if you got that. Okay, our next example is way down here, and it has a negative. So it's gonna flip the graph on its x-axis. So now that we got the hang, let's see, we'll do a few different numbers. Let's just do -1, 0, and 1. Okay, I think we got the hang of the general shape of the graph. So if you can do this all by your lonesome, pause the video and then fast forward to make sure you got the same answers. If you need help getting started, this is going to be -3 times 2 over 5 to the -1 power. Order of operations, we do the exponent first, so this is the same thing as -3 times 2 to the -1 over 5 to the -1. Okay, which they're unhappy upstairs and downstairs, so we're going to change them, and we're going to do -3 times 5 over 2. And then we multiply straight across, so we'll make that a -3 over 1. So that's going to be -15/2, or -7.5. Okay, so if you can do 0 and 1 all by your lonesome, please pause the video and try them. Just try it right now. Okay. So we have -3, 2 over 5 to the 0 power. Anything the 0 power is 1, so we have -3 times 1, which is -3. And then -3 times 2 to the 5th to the first power. That's the same thing as -3 times 2 over 5. So for fractions, we multiply straight across and we get -6 over 5. All right, so when I graph this, this is not quite the right setup for my grid, but we can deal with that. All right, so when we graph -1, -7.5, we'll call that -7.5. So when I graph -1, it's right about there. 0 is -3, and 1 is a little less, or a little more than -1. Okay, so we still have our magnetic force field, aka asymptote, aka y = 0 right there. And so what our graph is doing is it's reflected on the x-axis. So it's actually coming this way to the asymptote. So it's pulling the graph that way. to itself. So as long as you remember that the asymptote is a magnetic force field, you'll be okay. Right? And then our domain, write it down. You already know it. Write it down before I do. It's all real numbers. Our range, write this down. It's a little tricky. Since it's coming up to the asymptote, it's going to be less than or less than, oops, strictly less than 0. Okay. All right. So if you have a question about that, pause the video, write it down, ask me in class. Okay, your guided practice you can totally do. Example number 1 is just like example 1. 2 and 3 are just like we did. So you can totally do this. And you know they're decay functions because 2/3, 3/4, and 1/5 is less than 1. So keep that in mind, especially on the test, because you're probably going to have one of each. So you need to recognize which one's a decay and which one's a growth function. All right, now our friends are back. So please write this down. A times b to the x minus h plus k. Right? Right. A opens up or down, which means if it's positive, it's going to be a normal graph. If it's negative, it's going to reflect on the x-axis. Right? It's going to swing on the x-axis. H is horizontal, so H for horizontal. Again, at least our friends are consistent because H never changes. H is always the opposite. And then horizontal, just like the horizon. And K is the same, and it's up or down, vertical. Okay, and H is the BFF because it's closest to the variable, right? So, and then to graph, we're going to do the same exact things we did yesterday. We're going to create a t-chart for x equals 0 and 1. So write this down, please, so you get full credit for tomorrow. And then we're going to translate using the asymptote k because it's going to shift everything up, so that's why. And then we're going to translate the points from the t-chart using h and k. So if you're still writing this down, pause it, write it down, and then we'll do this example. All right, so we've got H and K. Okay. So please write down H and please write down K. Okay. You already know how to do this, so write down H and K. Okay, and as you said H was -1, you are correct, and K is -2. All right, so the very first thing we're going to do is we're just going to graph this part. So box that. Okay. The more work you show, the better it transfers to your long-term memory, and then that way you remember it for the quiz and the test. So whatever work I show, please show the same work so it transfers. Okay, so we know what the graph looks like, so we're just going to use 0 and 1. We could use others, but we're just going to use 0 and 1. So let's see. So if you know how to do this, please, and you should, because we did example 1 and 2. So pause it, figure out what the y values are right now, all by your lonesome. All right, so if you got stuck, then I will work it out. So we have 3 times 1/2 to the 0 power. Anything, so we want to do order of operations, so we do that first. Anything to the 0 power is 1. So this turns out to be 3 times 1, which is 3. Right. Next we have 3 times 1/2 to the first power. So that's going to be 3 times 1/2. Right. I'll change 3 into a fraction by doing 3 over 1. Multiply straight across and we get 3/2. Right. And now we're going to graph that. So step 1 is to graph that. Okay. All right. So we have 0, 3, make that a 3, and then 1, 3/2, so 1.5. Right. And we know it's a decay function, so we're going to start high and end low. But we're not going to touch the x-axis, we're not going to cross it, because this is what our asymptote is. All right, then we're going to translate using h and k. So we're going to take those 2 points. Our asymptote is now y equals -2. So we're going to shift the asymptote to -2. So our new graph is going to get really close to -2, but it's not going to touch it or cross it. So I'm going to take each point and I'm going to go back 1, horizontal change, back 1, and down 2. I'm not sure. back 1, down 2, probably right about there. And then take the next point and go back 1, down 2. Okay, and then redraw my graph. So it's going to get really, really close to my new asymptote, but not cross it or touch it. And then go ahead and write the domain and range before I do. Pause it, write the domain, pause it, write the range. Okay, if you put all real numbers for domain, you are great. If not, we'll still practice. All right, and the range, again, similar to what we did yesterday. So the range is going to be greater than, write it down before I do, -2. Okay, now if that didn't make any sense to you, please write down some sort of question and ask me tomorrow. All right, now we have our favorite. This is exponential decay. So write this down, pause it, write it down. And then A is your initial amount. So that new car that you drove off the lot for 20,000, once you drive it off the lot, it's considered a used car, and it depreciated in value as soon as you drive it off the lot, which is why a lot of people do not like to buy new cars. They prefer used cars. All right, rate is the percent decrease. Okay. So for example, I know that Hondas and Toyotas have a smaller percent decrease. They keep their value versus some of the other cars. And then T is the number of years. Okay. All right, and so that's what all of that means. So we're going to do an example with snowmobiles. So if you didn't quite write all of this down while I was talking, pause it, write it all down, please. Okay. And then snowmobiles, we're going to write an example. So please figure out what A is, all by your lonesome, what R is, and what T is. Okay. Right. What is A, what is R, what is T? All by your lonesome, you can do this. Okay. So if you said A was 4,200, great job. The rate was 10%. And if you turned it into a decimal, you get bonus points. Magic bonus points, but still bonus points. And then if you put 3 for number of years, good job. Okay, so we're going to write an exponential decay model. That's our first step. So we're going to put that all in that formula we just wrote down. So y is going to be equal to 4,200 and then times 1 minus my percent decrease, and then raised to the third power for the number of years. And then to simplify that, we have 4,200. This is 1 is like 1.00, so you're basically doing $1 minus 10 cents. So that would be 0.9 or 0.90 if that makes more sense. And then if we want to write the model, we're not going to quite do the 3 part yet. We're just going to leave it as t. So there is our model. That's the first step. And then now we're going to estimate the value after 3 years. So that's when we're going to replace the t with the 3. So we've got y equals 4,200 times 0.9 to the third power. So remember to do order of operations. So we do this part first and then multiply by 4,200. And you should get about $3,061.80. Okay, so that is what the snowmobile is worth in 3 years. Okay. And then after that, we're going to graph the model. So we can still use, we kind of know what it looks like. We have one value, right? We know when x equals 3, it's about $3,061.80. We also know when it's brand new. It is 4,200. So just using those points, we can graph. Alright, so we have, so this could be x is the number of years, And then y is the value of the snowmobile. Okay. So we have 2, so 0, we have about 4,200, so there's the y-intercept. And then about 3 years, if that's 1,000, this is about 3,000. So in 3 years, it's a little over 3,000. 4, 5, okay. And so we're just going to graph it like this. And then we're going to estimate. Okay. And if we wanted a more accurate graph, we'd have to graph more points, but that should work. And then so we graph the model. Now use the graph to estimate when the value would be about 2,500. So depending on how accurate your graph is, which the book is way more accurate because the book gets about 5 years, where this poor graph gets about 3.5 years. So it depends on how accurate your graph is, but as long as you've got everything lined up, it should be okay. All right. Again, if you have a question about that, pause it, write it down, and ask me in class. Okay. For guided practice, you can totally do these 4, 5, 6. Make sure you're only graphing this part, people. Okay, you're just graphing that part, and then you're shifting the rest. So you're only graphing this part and then shifting. You're only graphing this part and then shifting. So, and then 7 you can totally do. Number 8 you can definitely do. So, yeah. And if you need help with 8, I will help you. But that is the end of the lesson. So any additional questions, please write them down, and I will definitely help you.